standard deviation is one of the measure of dispersion. Okay, variation is the square of standard deviation. So variation, standard deviation tells us exactly the same thing. The way to calculate variation is you square the standard deviation value that you get, you will get the value for variation. Then you have a range. You know how to calculate range? It is highest minus the lowest value. Okay, so in this case, the highest is 2000, the lowest is 1800. So the range is 200. Okay.
Right. Yep. That makes sense. Yep.
So the three things, for measure of dispersion. So measure of dispersion is that value which is telling us how dispersed my data is. Okay. And then you have a measure of central tendency. It is telling me one data point that is representing my entire population. So when you look at any kind of data, you cannot look at only measure of central tendency, or you cannot look at only measure of dispersion, because you wouldn't know whether it is right or not. You would always have to look at it in combination. Mean plus standard deviation or median plus standard deviation, right? So I'll get what is the average, and also how much is it varying every time. Okay, are you good with what we have covered so far?
Yes.
Okay, so let me just take you through another. Just opening another presentation. I wanted to take you through one of the examples. So I was not able to download the GoToMeeting the application. Otherwise, I would have done all these things in the back end. Now you are able to see everything which is there on my screen. Okay, so I have prepared a lot of data, as well, which we will use in the course today. Let me just again expose you to my brilliant drawing.
Okay.
Let me see if there we go. I don't have to reinvent the wheel. I have it somewhere in the slides always. So here's the scenario. Right now you understand, what is measure of central tendency, what is measure of dispersion. So you know how you would want to look at data every time. So if I give you only average, only standard deviation, it will not be the sufficient information for you to take any decision based on that. Right. And so suppose you have to travel now for business, for work, or for vacation, and you want to decide which pilot would you want to fly with. We have got two options, pilot A and pilot B. So it's a plane that I picked up this particular image from the internet. That's the reason why it is so nicely laid out. So we have collected data on the plane landings of both these pilots.
Okay.
So there's a landing data for pilot. So for every airlines, whenever a airplane is landing, they have a safe landing zone, right? So if you are within that safe landing zone, you're safe. Otherwise, the plane would crash. Okay. So the blue lines that you see, which are running parallel to each other, these are the safe landing zone borders. Okay, and the asterisks or the stars that you see, these are the historical data of every time this pilot A has landed the plane. The good news is, Scott, pilot A has never crashed. He has always been within the safe landing zone. Okay. And then there is a pilot data for pilot B. Again, same thing. Pilot B has also never crashed. And we have studied the equal number of landings. So both the data points are exactly the same. Okay. Now you want to take a flight, and as the airlines, I've come to you, I've given you option here. Here is the landing details of pilot A. Here is the landing detail of pilot B, and of planes getting disappeared and plane crashes happening all across. We want to study this data every time we make a decision of boarding the flight. Okay. Cost of flight ticket is exactly the same. Okay, for flying with pilot A and pilot B. Now, as a customer, which pilot would you want to fly with?
Pilot B. Because he's consistently in the center of the safe zone.
Okay, but then both of them have never crashed. I mean,
Pilot A has almost crashed 9 times on the edge of the safe zone.
Right, he's all over the place.
Yeah.
I mean, he or the passengers have been very lucky. Right. So although he has never crashed, but he's all over. It's just about time. He would go off his normal behavior and go beyond these blue lines. And the moment he'll do that, he'll crash. Okay. So, but if I would have given you the data for average, so if you look at it, the average for both of these pilots would be this particular line. Right?
The averages might be the same.
Averages might be the same, but as a customer, you would not be bothered about the average. What you would be bothered about would be standard deviation along with the average.
Right.
Okay. This is what the entire Six Sigma is all about, Scott. If you are able to understand this, any process that you have, you would be able to understand what is it that you need to do in this particular process. Now, if I were to ask you what pilot A needs to fix,
then we'd look at pilot A's data and look for where the errors are occurring.
Where the errors are occurring, or if we look at the measure of central tendency, we know that in terms of central tendency, he's fine. He is still within the target, right? But then what is happening with the standard deviation, where he's varying too much? So the standard deviation is a problem here. Right? There's too much of variation. Every time he's landing, sometime he's landing here, sometime he's landing here. He's all over the place. So there's a big problem with the variation, big problem with the measure of dispersion. So we know that the treatment for pilot A is looking at the measure of dispersion and reducing the standard deviation. So, there are only 2 or 3 things that you can do in a Six Sigma project. One is either you can shift the mean, or you can work on the, or you can, sorry, I wanted to quickly take you away from the quiz. So I pressed some other button. There we are. So for any process, either there would be a problem with the centering or the mean. So remember that example that we took, and my paint is still open. 195, 200 is the bottling filling. But if my average is, let's say, 210, and again I'm trying real hard. Okay, and the average is 210. So we know that the problem is with centering or the central tendency. My process is not centered where I want it to be. I want to pick it up from here and keep it here. Because I want it within the specification limit, which has been specified by the customer, 201 and 195. You remember this example?
Correct.
Okay. But if I know I have a situation like pilot A, this is the area that I need to focus on. I need to reduce the variation, reduce the standard deviation. If the problem is like this, I need to shift the mean. Okay.
Yep.
Okay. Now that we have covered this, so this is what the concept of Six Sigma is. Six Sigma, remember I told you, Sigma is basically the standard deviation. So if you have a process, so there are two parallel lines. So this is USL, this is LSL. Now you understand what is upper specification limit and lower specification limit?
Correct.
Okay, so upper specification limit is if you go beyond this, there would be defect. Lower specification limit is if you go below this, there's a defect. Okay, so
right.
Sigma level is always calculated basis the upper and lower with respect to the target. And the middle line that we see here is the line for mean. Assuming our process is exactly, I'm sorry, go ahead.
That would be your mean in the middle.
Yeah, so right. You can say median, or here it is, so this is sign for mu, right? So it is mean. So there is a concept of normal distribution. So normal distribution is when you don't have too high or too low values in a given data set. At that point of time, it is okay to be using mean. So, in statistics, they teach us that, mean is not a very right representation always, but unfortunately, a lot of statistics has been written. If you look at, the standard deviation as well, in the formula, you would find that it is deducting from mean. So, a lot of analysis, a lot of statistical tests are actually based on mean itself. So, wherever possible, we should always work with the data where we can use mean. We will cover, how do we find out, whether we need to use mean or median. Okay, but in statistics, normal distribution is generally assumed. Normal distribution is when you don't have too high or too low values. So in the first one, process that you see on the extreme left hand side, this process, you see these portion here. You can see my cursor, right?
Right. Yep.
Okay, so you see this portion which is beyond the upper specification and lower than lower specification limit. These are the area where this particular process is creating a defect.
Yep.
Okay, and because this bell curve is so spread out, right, we know that the standard deviation is pretty high because it is so spread. It is 2 standard deviation here, 2 sigma. So the process is working at a 2 sigma level. What does it mean? That is that between the customer specification limit that the customer has given you and the mean, you are able to fit 2 standard deviations.
Okay.
Okay. You understood that? Shall I explain it again?
If the standard deviation is 100, that would be 200. Right? On each side.
Standard deviation with respect to mean. So if my mean is 0 and my standard deviation is 100, that would mean 200 here. And minus plus 200 here. I think they have written it other way around. So, so it should be plus here and minus here, ideally.
Okay.
Right. So it should be minus 200 here and plus 200 here. If my mean is 0.
Right.
Right. So, and assuming the target is plus 200 and minus 200. Okay. So this particular process is where I'm able to fit 2 standard deviation between the USL and LSL. Here in this process, if I make it, so see what I've done here, I have reduced the dispersion. You see here, it was beyond the upper and lower. Now the dispersion is reduced. It is well within 3, +3 and -3. But some portion going out, very little. So
Right.
in this kind of process, you know, we are able to fit in 3 standard deviation on the either side of the mean. Right? So if the standard deviation was 100 here, it would have been less than 100. Because now you are able to fit 3 standard deviation.
Okay.
Right? You with me?
Yes, I'm with you.
Oh, you already started yawning. So, you know, I've been giving LVC, so, you know, I can catch that. I'm just kidding. So, three sigmas here, or 3 standard deviations here.
Right.
Right. Now, if you look at the process, let's move towards right-hand side. Now, you look at this. Dispersion reduced further. Now, between mean and the customer specification limit, you can fit 4 standard deviation. In this, 5 standard deviation. Here, you can fit 6 standard deviation either side. Right? So, if you see this bell curve here, your process normally behaves like this.
Right.
Okay. Now, if assuming, let's say, there's a defect that is created. This is beyond the normal behavior of the process. Okay, there's a defect created here. It is defect for your process. You are beyond the normal behavior of your process, but still it is not a defect for the customer because it is still within the upper specification limit.
Okay.
Right? So only if you make your process so robust that, you know, there's a great deal of difference between upper and the lower and the dispersion or the normal behavior of your process. So basically what we have here is a buffer area.
Right. That makes sense.
Only then you will be able to reach a situation where you're only creating 3.4 defect per million opportunity. Otherwise, you know, it is very difficult level to achieve.
Okay.
You okay with this?
Because it's not a defect until it goes outside of the upper or lower. Okay. Yeah.
Absolutely. It might be defect for my process.
Okay.
Right?
Yeah.
But it might be not be defect from the customer point of view.
Correct.
Okay.
Yep.
So, you know, same example, again, to convert it into same example. If we look at it here, let's say pilot B lands here.
Keep him inside the lines.
Yes, he is. So he's right here, right? So normally he doesn't do that. There's a defect that he has created with respect to his own process.
Correct.
But still, you would still fly with him, right?
And that'd be considered maybe noise of some sort, wind
Absolutely.
or whatever. Right. Okay.
Some special cause, you know, he he dozed off while landing.
Right.
Still he didn't crash. Okay.
Got it.
So you need to make your process so robust, right? Only then you would be able to reach a 3.4 dpmo. Okay, let me just. Okay, so if you're able to, you know, give answers to this slide, Scott, you are able to understand the concept of Six Sigma.
Okay.
The entire concept. Then rest of it is going to be just going through some tools and techniques.
Okay.
Okay. So we know for any process, there can be a problem with centering and there can be a problem with variation.
Okay.
Okay. So if it's a problem with centering, what would you do? You would shift the mean.
Shift the mean.
Right?
Right.
If it's a problem with the variation, what you would do? You would reduce the variation.
It's a standard deviation. Yep.
Right? This is standard deviation or variation. Right.
Mm-hmm.
What do you think the problem? So the yellow circle in between, this is the target.
Yep. Archery target. I got you.
Right? What do you think is the problem in scenario A?
Standard deviation.
Absolutely. Bang on. The project should target reduction of variation.
Mm-hmm.
Scenario B.
Centering.
Centering. All we need to do is pick it up from here and keep it here.
Shift it. Yep.
Shift the mean. Scenario
Shift the mean.
C?
Spot on.
Spot on. Absolutely. Ideal situation. This is how we want our process to look like.
Yep.
There you go. You got it, Scott. So you are half Greenbelt trained.
Half. I'm halfway there. All right.
Right. So you understood the concept. Now we'll just go through some of the tools.
Okay. Want to take a quick break?
Remember the... Oh, just one second. Let me just go back. So I'm just getting into the flow now. Let me just go back to the slide that I showed you. And let's see where we are. You see this slide, you had a practical problem.
Mm-hmm.
You converted into a statistical problem. What is a statistical problem? Problem with the mean or variation. Right? So when you know exactly you need to shift the mean or you need to reduce the variation, you have already come to the second step, which is you have converted the practical problem into a statistical problem. Okay? All we need to do now is to find a statistical solution and a practical solution. That's it.
Okay.
Okay, so I am moving back to the slide.